Okay, welcome guys. Hopefully you're not all going too stir crazy over the last 2 weeks. We're going to look at the second half of localization of function today. So today we're going to be evaluating the idea of localization of function. So just to recap, localization of function is the idea that specific parts of the brain carry out very specific functions. This can be contrasted with holistic theories, which kind of say that the whole brain works together as one to carry out those functions. So last lesson we looked at some examples of the specific brain regions associated with certain functions, so some examples of localization, such as Broca's and Wernicke's area. And today we're going to look at the evidence for and against localization of function. So we can use a variety of case studies where damage to a very specific brain region causes loss of certain cognitive or behavioural abilities. So for example, Broca's research, where he showed that damage to this area here, which he then called Broca's area, led to issues with speech production. And from that he concluded that this brain area must therefore be responsible for speech. So this is a strength of localization of function, because it suggests that some functions are in fact localized to a specific brain region. In this case, language production is localized to this specific brain region here on the cerebral cortex. However, modern neuroimaging studies have actually shown that Broca might have underestimated the extent of the damage. So Dronkers et al. Carried out an MRI scan on Tan's brain, and I'll show you that in a second, but basically what they found is that more brain areas than just this Broca's area here were actually damaged, and Broca didn't realise that at the time. What this means is that actually more brain regions were damaged, which means that maybe it wasn't just the damage to Broca's area which was causing issues with speech production, but actually multiple different brain regions were all involved. This would obviously therefore mean that multiple regions are involved in speech production. Therefore, we can't say that speech production is localized to one specific area. So this is the actual brain of patient Tan, the guy who could only say Tan over and over again. And you can see here, this is the front of the brain here, this is the back. And so you can see here, this is Broca's area. The most obvious damage is here. But if you look at Dronkers et al., what they found is that you actually have massive amounts of damage here further towards the back, which you can't see just by looking at the brain in the same way that Broca did. He just looked at the brain. But in the MRI scan, we can see that these deep brain structures closer to the middle of the brain here, towards the back, are actually quite badly damaged, especially if you look here, comparing it to the other side. You can see massive areas here where there's damage that you just can't see from the surface. So this is actually suggesting that this brain area and this brain area are kind of both associated with that loss of speech production, not necessarily just Broca's area as he observed. So another argument against localization of function is equipotentiality theory, and what this means is that only very basic functions can be localized to specific brain regions. So we can say that raw visual information from the eyes might well be processed in a very specific place, so the occipital lobe, but actually more complex higher brain functions such as speech, understanding what we see, so perception, as well as problem solving and decision making, for these higher brain functions the entire brain actually does work together. So this is a holistic theory. So according to equipotentiality theory, following a brain injuries, other brain areas can actually sometimes take up the functions which were initially impaired. So for example, if you are a stroke patient and you take damage to your motor areas, what you might then find is that you have difficulty moving, but through rehabilitation you might find that actually other brain areas besides the motor areas which were damaged start to pick up the slack. So even though those brain areas wouldn't have been involved with movement before, they are now involved with movement because the area which had been used has become too damaged. This demonstrates that actually functions are not localized to one specific brain region, because if that was true, then we wouldn't be able to have a different part of the brain take over that same function. Similarly, in most people, the occipital lobe, as I said, is responsible for processing visual information. However, in blind people, obviously, there is no visual information to process. So the occipital lobe doesn't just sit there doing nothing. Actually, what it instead does is takes over some other functions that the brain needs it to do. So when blind people read Braille, which obviously uses their tactile senses because they read with their fingers, despite the fact that tactile sensations are usually processed in the parietal lobe, in the somatosensory area, in blind people, the occipital lobe becomes active as well. So even though we're claiming that visual information is localized to the occipital lobe and tactile, so physical feeling information, is localized to the parietal lobe, we're seeing here that that isn't actually true in every single case. So again, if brain regions can carry out different functions to what we're claiming they are supposed to be for in certain situations, this calls into question this idea that functions can be localized to a specific brain region. And finally, connections between different brain areas might actually be just as important, if not more important, than those areas themselves. So in order for the whole brain to work together to carry out functions, as equipotentiality theory suggests, those areas must be able to communicate with one another. Now, if this is true, then damage to the connections between brain areas should cause impairment of function, even if those brain areas themselves are not damaged. So Desjardins in 1892 found that damage to the connection between the visual cortex and Wernicke's area led to an inability to read. So the visual cortex is obviously associated with vision, and Wernicke's area is associated with understanding speech, understanding the meanings behind language. So in order to read a sentence, you need to be able to see it, and then also be able to make sense of the word that you are reading. So even though in this case the visual cortex wasn't damaged and Wernicke's area wasn't damaged, because there was no communication between these two areas, they still weren't able to combine those two functions to be able to carry out the higher order function of reading. So this demonstrates that higher brain functions like reading are not localized to a specific reading area, but actually they rely on lots of different areas, which each might carry out its own basic function, working together to carry out more complex functions.